Hello everyone, welcome to Piso Physics. I hope you people are doing well. In this particular video, we are going to discuss about variation in time period of pendulum clocks by thermal expansion, right? Consider we have one pendulum clock which has length L, right? So its time period will be T equals to 2 pi square root of L divided by G. Now, if we increase temperature by delta T, so new length will be L dash. So new time period T dash will be equals to 2 pi square root of L dash by Z. Okay. New time period T dash will be equals to 2 pi square root of initial length L 1 plus alpha into delta T divided by G, right? So T dash will be equals to 2 pi square root of L by G into square root of 1 plus alpha into delta T. This is our old time period, which is T dash equals to T into, here we have 1 plus alpha into delta T, which has power half, right? So by binomial expansion, 1 by 2 will be here. So we have 1 by 2 alpha into delta T. Okay. So here we can write it as T dash equals to T. We will now open the bracket, so it will be plus T by 2 alpha into delta T. Therefore, T dash minus T will be equals to alpha by 2 into T into delta T, right? So change in the time will be equals to alpha by 2 into time period T into delta T. Now here we can have two cases. First case in which delta T is greater than 0. Therefore, delta T also will be greater than 0. That means T dash is greater than T. So we can say that clock will be slowed down. Why? As we know, time period for the oscillation will be increased, then time shown by the clock will be also slow. Our second case is if delta t is less than 0, therefore delta small t will be less than 0, therefore t dash will be less than t. It means clock will be fast. So that's our two important cases. Now let us solve one numerical so we can get better idea. Clock with a metallic pendulum is 5 seconds fast each day at a temperature of 15 degrees Celsius and 10 seconds slow each day at temperature of 30 degrees Celsius. Find the coefficient of linear expansion for the metal. So as we know 5 second fast, that means for the first case delta t is minus 5, and suppose if initial temperature is T naught and final temperature here we have 15 degrees Celsius. So we had one formula delta T equals to alpha by 2 into T into delta capital T. So we will have here minus 5 equals to alpha by 2 into delta T. So final temperature minus initial temperature, that will be 15 minus T naught into small t. That means here we have to take 5 seconds fast each day. So time will be for the day. So that is 86400 seconds. So we can here write 5 equals to alpha by 2 t naught minus 15 into 86400. Similarly, we can here write as 10 equals to alpha by 2 into 30 minus t naught 86400. Let us take this equation as first and this equation as second equation. Now if we divide both the equation, we will have 1 by 2 equals to t naught minus 15 divided by 30 minus t naught. So 30 minus t naught will be equals to 2 t naught minus 30. So, so here we will have 3 t naught equals to 60 degrees Celsius. So T naught will be 20 degrees Celsius. Now let us put this T naught into one of the equation. From that we will get alpha equals to 2.31 into 10 power minus 5 degrees Celsius inverse. So that's how we can solve this kind of thermal expansion numericals.